Hello and welcome to the 6th video in the C4, the periodic table revision series. This video is on metallic bonding and superconductors, and my name is Mr. Clee. Right, the aims of watching this video, by the end of it, I'm hoping that you should be able to describe metallic bonding in terms of structure and link the properties of metals to this structure, explaining why they have the properties that they have. Also, you should be able to explain what a superconductor is and give some potential uses and advantages and disadvantages of using them. Okay, so in a metal, when metals are bonded to each other, what you end up with is positive metal ions surrounded by delocalized electrons. These delocalized electrons almost act like a runny glue that's sticking the metal ions together. Because obviously you couldn't have two positive ions attracted to each other because the positive charges would repel, so there needs to be a negative glue, if you like, sitting between them. I say that it's a runny glue because these delocalized electrons are not attached to any particular ions individually and are free to move. So these electrons can move all the way through this material as they see fit. Because these electrons can move, this is the reason why metals conduct electricity. Free electrons, movable delocalized electrons, can carry charge around a circuit. Also, the bond, the attraction between the delocalized electrons and the metal ions is a very, very strong bond. Because of this, generally speaking, although there are a couple of notable exceptions, metals have really high melting points and really high boiling points. They also tend to be, because of the high bonds, they tend to be a very, very strong material, extremely hard, but also have a certain amount of flexibility. They can be bent out of shape and will maintain those shapes. Here we have a number of different uses of metals, chosen for various different reasons. So let's take, for example, situation here. This metal has been chosen probably in part because of its strength, but also because it's lustrous. I would say that the aeroplane here, the reason that the metal has been chosen for that one will have something to do with strength, but a lot to do with density, because obviously flying things need to be light. Probably something to do with resistance to corrosion. Often they give you a lot of situations in exams where they say, which is the best metal for using in terms of this? And you need to justify that choice in terms of melting point, boiling point, density, cost, and various different things. For example, you could use silver to make electric cables, but you wouldn't use silver to make electric cables because it's very, very expensive. So focusing on the electric cables, the sort of things you'd be looking for would be electrical conductivity. Now, electrical conductivity might lead you to a metal like copper. However, copper is quite corrosive, so you might not want to use that one. You might be looking at density. These wires are up in the air, so because they're up in the air, they don't want to be very heavy, because the heavier they are, you have to support them. You might want to look at how much they corrode, whether it's a corrosive metal, because you don't want things that are going to rust. They're going to have to be replaced very frequently. And, of course, the one that is always taken into consideration is cost. Whenever justifying a choice of metals, you have to justify how expensive it is. This might be an example that you might get given. What you've got here are two factors, two properties of metals. You've got copper, aluminium metal and stainless steel, and you've got their strength and their ability to conduct heat. You might get asked about which one you'd use for constructing a bridge. And in this situation, you'd probably be talking about stainless steel, because the most important factor when constructing a bridge like this one, which is the Millennium Eye in Newcastle, is how strong that material is. How well it conducts heat is not that important. You're not making a saucepan, but if you were making a saucepan, you'd probably choose copper. Moving on to superconductors. A superconductor is essentially a material that has very little or even no resistance to the flow of electricity. Resistance comes from the electrons within the metals, when they move through, sometimes they collide with the positive metal ions. This leads to inefficient transfer of electrical energy, and things with high resistance get hot. You might well have seen me do the burning pencil of death experiment, where the graphite, which has got high resistance, transfers a lot of energy as heat because of the high resistance, which means it's an inefficient conductor of electricity. Superconductors are the opposite of that. They have very, very little resistance, so hopefully are really, really good conductors of electricity. There's a couple of things that superconductors are really useful for. One of them is making electromagnets, very, very powerful electromagnets. This electromagnet here is in an MRI scanner, which is used to get detailed images of soft body tissues. You might have had an MRI scan. Basically, it's used where you need to image soft tissue rather than an X-ray machine. Another very interesting way of using superconductors is in this situation here. This is a maglev train. Maglev trains can get ridiculously high speeds, like 600 kilometers an hour. The reason for this is because they are not in contact with the rail. So because they're not in contact with the rail, there is zero friction. So the force pushing them forwards only has to counteract air resistance. It essentially floats above the track. Other more run-of-the-mill things that you could use superconductors for, essentially what we've got is potential for really, really fast electrical circuits, which means very, very, very powerful computers, and the potential to transfer electricity through the national grid and waste very little electricity. That would make the whole system more efficient, making electricity cheaper to produce and reducing the amount that we needed to make, therefore reducing the amount of associated pollution from generating electricity through non-renewable sources. However, there is a major drawback, and one of the things at the moment is that superconductors only really work at extremely low temperatures, so they have to be super cooled. Maglev trains use liquid helium and liquid nitrogen to cool down the superconductors and mean that they work effectively. One of the holy grails for scientists working in this area, research scientists, is to try and find materials that become superconducting at room temperature. That would mean that the benefits of using them outweighed the energy demands from creating the liquid nitrogen and liquid helium that are needed and used currently to cool them down. So, in summary, in a metallic bonding, what you have is positive metal ions sitting in a sea of delocalized electrons, which lead to strong, malleable materials with high melting and high boiling point. They're also really good conductors of heat and electricity. Superconductors are materials that conduct electricity with little or no resistance. They are used in things like MRI scanners, maglev trains, and we could potentially use them for carrying electrical current around the national grid, or in really, really powerful computers. However, we've got this problem with them at the moment in that they only work at very, very, very low temperatures. Thank you very much for watching. My name is Mr. Clee, and the next video in this series will hopefully be available soon.